Hey class. So today we're going to be doing a 2.1 and 2.3 review. I'm going to spend a brief moment talking about all the things that we talked about in these sections, but I want to spend the majority of my time doing example problems. So uh, first things first, we talked about like terms. And remember that like terms had some coefficient, right? And they had some variable raised to some power. So 3v squared and v squared are like terms. 3v squared, its coefficient is 3. Just v squared, its coefficient is 1. And whereas something as like b squared and b are unlike terms. So this was what we went over, and we talked about how we could combine these. So if we saw something like 3v squared plus v squared in an equation, we could simplify this to simply 4v squared. When we combine like terms, we add their coefficients, right? And this is what 2.1 was all about. Then we turned to 2.2. In section 2.2, we talked about the topic of linear equations. And linear equations are of the form ax plus b is equal to c. And for any given a, b, and c that are real numbers, we can find a solution of x, and then x will just equal some number, right? And why we talked about that is because we wanted to talk about the addition property of equality. And the addition property of equality states that if a equals b, then a plus c equals to b plus c. These two are equivalent equations. So these are equivalent equations. And remember, that equivalent that we learned from chapter 1 just states that they have the same solution. So this means we can add or subtract real numbers from both sides of the equation. And then lastly, in chapter 2.3, we talked about the multiplication property of equality. And this property just states that if a equals b, then a times c equal to b times c are equivalent. So these two are equivalent. And remember that while in the addition, you didn't have any stipulations other than a, b, and c are real numbers. Let me write equivalent first. Okay. But in the multiplication property of equality, c cannot equal 0. So c does not equal 0. And that's the only restriction. Okay, let's get into some examples. Okay, so here's our first example. And in the first example, we're just going to go over simplification. Now, whenever you see the word simplify, we're just going to combine like terms. So this just really means to combine like terms. Okay. And when you combine like terms, for instance, these two, as you can tell, they both have x and some coefficient. So we can combine these to make it 3.7x. We have a negative 6.4 and a positive 5. So we can combine those, and that'll be negative 1.4. So let's just write down what we have so far. We have negative 3x plus 3.7x. And then, like I said, negative 6.4 and 5 is negative 1.4. Okay, and then we just combine it to 0.7x minus 1.4. Now notice that we didn't get an answer that says x equals. That's because we're just simplifying. Okay, here's our second simplify example. And before I start, I just want to remind everyone that I want you guys to be taking notes. I only expect you to take notes of the example problems in this video, since we've already gone over 6.1 through 6.3 in class. Okay, additionally, I want you guys to pause the video whenever you see an example and try to solve it yourself. And then I'll go ahead and solve it, and you can press play on the video. So go ahead and pause the video, and I'll start solving it after. So here we want to distribute this 2 in order to get rid of these parentheses. So we have negative 6x plus 8. And then we're going to have plus 8x minus 5. So remember the multiplication rules. If you have a negative positive, positive negative, these are negative. If you have a negative negative or a positive positive, these are positive. Okay, so keep those in mind. That's for multiplication. And then we just combine like terms to get 2x plus 3. So hopefully everybody could follow me there, and let's go on to another example. Okay, here's our third example. Go ahead and pause it and try to solve. Now, this problem is a little tricky. Very simple once you notice which powers go together. So this is x squared times y, okay? Now, the next term doesn't have x squared plus times y, but this third term does. So these two are like terms, whereas this one has no like term to combine with. So we can just simply add 2 and 3 to get 5x squared times y minus 4xy squared. So it's simple, but just be very careful of the powers on the exponents. Here we have a word problem, or more like a algebraic phrase that we want to translate into an expression. So we want to subtract 2x minus 10 from 5x plus 5. So we start by just writing 5x plus 5, or plus 7, and then we put minus parentheses 2x minus 10. The parentheses is important because you need to subtract the 2x, but you also need to subtract the negative 10. So when we do this, we distribute the negative sign, and we get 5x minus 2x plus 7 plus 7 plus 7 plus 10, sorry. So our answer is simply going to be 3x plus 17. Here we have our first example where we have to try to solve for x. And when we see the word solve, you need to think isolate variable. So we want to isolate the variable on one side of the equation and have just a number on the opposite side of the equation. Okay, so when we approach these, I personally like to solve for x first, or just get all the x terms combined. So I see this negative 5 over 7x, and I recognize that if I add that negative 7x to both sides, then I'll get a whole x over here. So I want to add 5 over 7x to both sides. And we end up with x on this side plus 6 equal to plus 7 on the right-hand side. Okay, now we want to isolate x, so we subtract a 6 to both sides. And we see that x is equal to positive 7 minus 6 is equal to 1. And that's our solution. You can always check a solution by plugging your solution back into your variable x, but if you're fairly confident of your steps, this isn't necessary. Here we have another example, but before we get into the multiplication part of it, I wanted to talk about reciprocals. So if you're ever told to find the reciprocal of something, just remember that the definition of reciprocal is that they both multiply to 1. So a and 1 over a are reciprocals because when you multiply them together, you get 1. So here we have a negative 1 over 5. So you want to know, what do I multiply negative 1 over 5 to get 1? And the answer is negative 5. Because if I multiply 1 over 5 by 5, those cancel out, the negatives become a positive, and we get a positive 1 from multiplying them. Therefore, negative 5 is the reciprocal of negative 1/5. And here's our last example. So we're trying to solve, so that means we need to isolate x. And we have a number multiplying x that isn't 1. So we're going to have to use the multiplication property of equality. Before we do that, we want to get x alone with its coefficient on one side. So we add 5 to both sides of this equation. And when we do that, we get x over 4 on the left-hand side And to the right-hand side, -7 plus 5 is -2. Now we look at the coefficient of x and multiply both sides by the reciprocal. So since the coefficient of x is 1/4, we multiply both sides by 4. When we multiply both sides by 4, on the left-hand side we're just left with x, and on the right-hand side we find -8. So -8 is our solution. And that is the end of this video. Hopefully this helps, and I'll see you next time.